Starting off logic and truth tables, this is statements, negations, and quantified statements. Is something true or false? We're going to be dealing with that. Learning intentions for this lesson. The students can identify English sentences that are statements. The student can express statements using symbols. The students can form the negation of a statement. Students can express negations using symbols. The students can translate a negation represented by symbols into English. And students can express quantified statements in two ways. The students can write negations of quantified statements. Let's go. History is filled with bad predictions. Here are examples of statements that turned out to be notoriously false. Fake news nowadays. Back in 1899, everything that can be invented has been invented. Charles H. Duell, Commissioner, U.S. Office of Patents. Back in 1902, the actual building of roads devoted to motor cars will not occur in the future. Harper's Weekly, August 2nd, 1902. Here's another one. Televisions won't be able to hold on to any market. People will soon get tired of staring at a plywood box every night. No longer plywood, but Daryl F. Zanuck, 1949. And there's no chance that the iPhone is going to get any significant market share. No chance. Steve Ballmer, Microsoft CEO, 2007. Statements and using symbols to represent statements. So, definition of a statement. A statement is a sentence that's either true or false, but not both simultaneously. Two examples. London is the capital of England. That's a statement. William Shakespeare wrote the television series The Big Bang Theory. That is also a statement. We have not addressed the true or false nature of either of those, but I predict we're going to in the future here. A statement that can be written in if-then form. Those are conditional statements. Symbolic form. P implies Q is P arrow Q. So if P, then Q, or P implies Q. The hypothesis is the phrase that immediately follows the if. So P is a hypothesis. Conclusion is a phrase that immediately follows then. So Q is the conclusion. Identifying the hypothesis and conclusion, here's an example. If you live in Nashville, then you live in Tennessee. Hypothesis. If is our red flag that is coming next. It's not part of it. So you live in Nashville is the hypothesis. Then is the red flag that the conclusion is coming after it. It's not part of it. You live in Tennessee is the conclusion. If-then form. If P, then Q. Write the given statement in if-then form. States on the East Coast border the Atlantic Ocean. So if a state is on the East Coast, then it borders the Atlantic Ocean. That's putting that statement in if-then form. Negations. The negation of statement P is expressed by writing that symbol in front of the P. We read it as not P, or it is not true that P. It depends on the situation which way we are going to word it, but that's negation, not P. So the opposite truth value. Negations, example 1. Let P and Q represent the following statements. So the ones we saw before. Let's do P first. Shakespeare wrote the television series The Big Bang Theory. And Q, today is not Monday. We need to express each of the following statements symbolically. So Shakespeare did not write the television series. So P is saying he wrote it. This is saying did not write it. So that is not P. Let's look at Q. Today is not Monday, but part B down there is saying today is Monday. So that would be not Q. Negations, try this. Examples expressing negations symbolically. Let P and Q represent the following statements. P is Paris is the capital of Spain. Let's do part A. Express each of the following statements symbolically. So look at P. Paris is the capital of Spain. And down here for A, it says Paris is not the capital of Spain. So that is not P. Q, July is not a month. But if we look down at part B, it says July is a month. So that is the opposite. So that is not Q. Negations, translate into words. Example, let P represent the following statements. P, the United States has the world's highest divorce rate. Now, we don't know if that statement is true or false, so be careful expressing the symbolic statement, not P, in words. So we can't say it's not true because we don't know if it's true or not to begin with. But the United States does not have the world's highest divorce rate, would indeed represent that symbolic statement. More negations, example, let Q represent the following statement. So Q is Chicago O'Hare's is the world's busiest airport. And we want to express the symbolic statement, not Q, in words, the negation. So we need to change is to not is or is not. Chicago O'Hare is not the world's busiest airport. Related conditionals, and we'll do more with these later, just threw them in. Inverse is formed by negating the hypothesis and conclusion. So it's not P implies not Q, and we'll do more with implies later on in the next lesson. Converse is formed by switching the hypothesis and conclusion. So Q implies P. Contrapositive is formed by negating and switching the hypothesis and conclusion. So that's not Q implies not P. We'll be doing more with those later. Quantified statements. In English, we frequently encounter statements containing the words all, some, and no or none. These words are called quantifiers. A statement that contains one of these words is a quantified statement. Here are some examples. All poets are writers. Some people are generous. No common colds are fatal, and some students do not work hard. Quantified statements. Using our knowledge of the English language, we can express each of the quantified statements in two equivalent ways. That is, in two ways that have exactly the same meaning. Statement, all A are B. An equivalent way to express it is there are no A that are not B. Example, All poets are writers. There are no poets that are not writers. Here's another statement. Some A are B. So there exists at least one A that is a B. Okay, if some of them are B, then at least one A must be a B. Example, some people are generous. At least one person is generous. Next statement. No A are B. All A are not B. That's an equivalent way to express that statement. Example, no common colds are fatal. All common colds are not fatal is another way to express it equivalently. Last one, some A are not B. So not all A are B. So some students do not work hard. Not all students work hard. I wish they would. Forming the negation of a quantified statement, suppose we want to negate the statement, all writers are poets. Because this statement is false, the negation must be true. The negation is not all writers are poets. This means the same thing as some writers are not poets. Notice that the negation is a true statement. Here's our diagram that shows the statement, all writers are poets. So writers is a subset of poets. The negation, some writers are not poets, shows an overlap where some of the writers are, but not all of them are. In general, the negation of all A are B is some A are not B. Likewise, the negation of some A are not B is all A are B. Investigate how to negate a statement with the word some. Consider this statement, some canaries weigh 50 pounds, and that is in that first Venn diagram. Negation, it is not true that there is at least one canary that weighs 50 pounds. So this is the same as some canaries weigh 50 pounds. That's our original statement. And we have in our Venn diagram an overlap of canaries and 50-pound objects. But if we look at the negation, some canaries weigh 50 pounds. The negation, it is not true that there's at least one. So if there's not at least one, then there's no overlapping circles, as in that diagram off to the right. So in general, the negation of some ARB is no ARB. Likewise, the negation of no ARB is some ARB. Is there a way to remember the negations of quantified statements? Here's an example. All A or B. The negation of that are some A are not B. Some A are B. The negation of that is no A are B. Let's do some examples and number them. Number one, statement one, all humans are mortal. So the negation would be some humans are not mortal. Statement two, some students do not come to class prepared. The negation of that is all students come to class prepared. Let's do that. Number three, some psychotherapists are in therapy. Negation, no psychotherapists are in therapy. Number four, no well-behaved dogs shred couches. Negation, some well-behaved dogs shred couches. Negating a quantified statement. Here's an example. The manufacturer of my smartphone told me all known safety issues have been resolved. Later, I learned that the manufacturer never tells the truth. Bad for manufacturers to lie to us. So what can I conclude? We need the negation of that. So then the negation of all known safety issues have been resolved would be some known safety issues have not been resolved. Or at least one safety issue has not been resolved. Negating a quantified statement. Here's another example. The Board of Supervisors told us all new tax dollars will be used to improve education. Sounds like a good idea to me. I later learned that the Board of Supervisors never tells the truth. Boo on that. So we need the negation. Okay, what can we conclude? The negation, and express the conclusion in two equivalent ways. So some new tax dollars will not be used to improve education. That would be a negation of the statement above. Or at least one new tax dollar will not be used to improve education. Unlock your potential and do great things. Vicki Gaines, see you later.